So, when you picture a 40-ton cement mixer, what comes to mind? Probably a lot of noise, dust, just raw brute force, right? But I bet the one thing you're not thinking about is user experience design. Well, what if I told you the screen inside that truck's cab could be the only thing standing between a totally normal day and a catastrophic multi-million-dollar disaster? Today, we're going to break down a really fascinating engineering report that looks at exactly that: how to design a super high-stakes interface for one of the absolute toughest jobs on the planet.
So here's the core of the problem, right? Think about a traditional diesel truck. The driver gets all this constant feedback. The roar of the engine when it's under load, the vibration of the hydraulics. It's a conversation. But these new hybrid and electric systems, they're silent. And that silence has literally cut a critical sensory link that drivers have relied on for generations. It creates this whole new world of anxieties. Like, is this high-voltage system safe? Is the machine even on?
So, to tackle this, the design team came up with a core philosophy they call the translator. And the idea is pretty simple, but it's powerful. The human-machine interface, or the HMI, it can't just be a screen that's throwing numbers at you. No way. It has to be a bridge. It has to translate all that silent, super complex data coming from the truck's brain into a language that a driver who's under a ton of pressure can understand and act on instantly. All right, so where do you even start with a design like this? Well, you start with the real world, the physical reality of the user's environment. And let's be clear, this is no office. We're talking about a noisy, vibrating, and usually pretty muddy construction site. Okay, so first things first, a super strict separation of duties. That screen right in front of the driver, the digital cluster, that is a safety-only zone, a sacred space, if you will. It only shows the absolutely non-negotiable stuff: speed, brake air pressure, high-voltage system status. Nothing else is allowed to cover that up, ever. Now, the center screen, that's for all the other tasks. Navigation, cameras, fleet management stuff. It's a tool, not a second dashboard. Big difference.
Now, what's so brilliant about this is how these aren't just guesses. They're all backed by hard data. I mean, the designers have to think about someone wearing thick, dirty work gloves. So touch targets on the screen, they have to be massive, at least 20 by 20 millimeters. And there has to be a 5 millimeter gap between them, all to prevent what they actually call the fat finger effect, which is exactly what it sounds like. It's a super simple, data-driven solution to a very, very real problem.
And the design challenge gets even tougher when you move to the back of the truck. This is where the really dangerous work happens, controlling the flow of concrete. So the rear control unit, the RCU, it has to be, well, basically bomb-proof. We're talking an IP67 rating, which means it can literally be submerged in water. It has to survive getting blasted with a high-pressure washer and being completely caked in concrete every single day.
And all of this brings us to a fundamental, non-negotiable rule of engineering in this field. You never, ever rely on a touchscreen for a life-or-death function. The emergency stop, the emergency drum reverse, those have to be big, physical, hardwired buttons, period. Because when things go wrong, a driver's muscle memory needs to slam a button, not try to navigate through a menu.
So with the physical interface pretty much sorted out, the next challenge is a psychological one. It's all about solving that problem of the silent hybrid system. How do you make something that's totally invisible, the flow of energy, feel completely intuitive to the driver?
The way the HMI does this is actually pretty cool. It visualizes energy as a simple, dynamic flow of light. So when the engine is doing the work, you see this orange stream flowing to the wheels. When the electric motor kicks in to help on a hill, a blue stream joins right in. And when you're braking, a green stream flows back to the battery, showing that you're recapturing energy. The goal here isn't to show a bunch of engineering data. It's for the driver to know in a single glance the answer to one simple question: am I spending energy right now, or am I saving it?
But for a cement mixer driver, range anxiety isn't about getting stranded on the side of the road. Oh no, it's about something way, way more costly. They have a special name for it: solidification anxiety. Just think about it. If the battery dies while they're on a job site and that drum stops spinning, the entire multi-ton load of concrete inside can harden, and that completely ruins the drum, a repair that can easily cost hundreds of thousands of dollars.
And the solution to this is it's elegantly simple. Instead of showing the driver a battery percentage, which honestly doesn't tell them what they need to know, the system calculates and displays the one number that actually matters: time to solid. It's a clear, color-coded countdown timer that directly answers the driver's single biggest fear. It literally turns that anxiety into confidence.
All right, so now let's talk about what happens when things go wrong. Because a really good HMI doesn't just show you information when everything's fine. its most important job is to manage a crisis and stop a small problem from spiraling into a total catastrophe.
And the biggest challenge here is actually a psychological one called alarm fatigue. It's the whole boy who cried wolf problem, right? If a system is constantly bombarding the driver with pointless beeps and warnings for every little thing, guess what? The driver's going to start tuning them out. And that includes the critical ones, the ones that really, really matter. So the system has to be smart. It has to know when to speak up and, just as importantly, when to stay quiet.
The solution they came up with is this 4-level alert pyramid. It's brilliant. A level 1 info alert, that's just a little silent icon. No big deal. A level 2 warning bumps it up to a yellow pop-up and a single beep. But a level 4 fatal fault, we're talking something like a high-voltage system failure, that triggers a full-screen red takeover and a blaring siren. The message is unmistakable. Stop and get out of the vehicle now. The system's response is always perfectly scaled to the level of risk.
And this, right here, is that translator philosophy in action. The HMI is absolutely forbidden from showing a driver a raw fault code like P0A0D. I mean, what are they supposed to do with that? Nothing. Instead, it must translate that code into plain English. It has to tell them 1, what the problem is, 2, what the risk is, and 3, exactly what they need to do about it, right now.
But the HMI's responsibility doesn't just stop at the cab door. Its job has to extend the driver's awareness out into those huge, dangerous blind spots that surround a massive vehicle like this. And that's where some really clever, intelligent safeguards come into play.
These safeguards are called interlocks. And basically, they're smart rules programmed right into the system to automatically prevent common but really dangerous mistakes. For example, if the truck is moving faster than, say, 5 kilometers per hour, the system physically will not allow the drum to go into reverse. It's not a warning. The system just says no. It uses code to prevent human error before it even has a chance to happen.
And look, this isn't just about having some good ideas. This is about certified, life-saving design. The software that displays critical information, like your speed or a brake warning, has to meet this incredibly rigorous standard called ISO 26262 ASIL-B. The easiest way to think about it is like an official safety rating for the software itself. It's a guarantee that the system will work, that it's functionally safe when you need it most. So how do they achieve that level of safety? They use a really advanced software architecture called a hypervisor. Just think of it like a digital firewall inside the computer. It actually runs 2 completely separate operating systems on the same chip. One is dedicated to the safety-critical stuff, like the dashboard. The other one runs all the features, like navigation and the radio. And this creates a wall, ensuring that even if your navigation app completely crashes, it can never, ever, ever affect your speedometer.
And this really brings us right back to the core theme of this entire design report. It's a philosophy that's both powerful and, honestly, pretty humble. The goal isn't to build some super intelligent, all-knowing system that does everything for you. No. The goal is to build a tool that helps a human being who is under immense pressure make the right decision at the right time.
Which, of course, leaves us with one last big question to think about. As technology and automation get more and more woven into every part of our lives, especially in these kinds of high-stakes jobs, what's the ultimate goal here? Is the best technology the kind that tries to replace the human operator? Or is it the kind that strives to be a more reliable, more intuitive, and ultimately, a better partner?